First thing you're going to do, the conservative or not, is checking if it is a gradient vector field, and if so, compute the gradient vector field. And in that process, you already computed the what was the different name that I used instead of an antiderivative? I call this one as a potential function. There's a common name in physics and math also. The function, the scalar function f for the vector field in there. All right, this is an exercise. We've been integrating this one first, but there's nothing special about x, and either direction is okay. Okay, so this is our exercise number 1. Write down this vector field in xy plane, 2 components, x component 2xy sine of x squared y component like that, sum of 2 things. Is this conservative or not? First thing you will try usually is test if it's a gradient vector field or not, right? All right, how was it? Yes, sir. Which part? Are you talking about this part or that part? Number two? First line here? 0 plus sign. Well, f of xy, I figured out it must be in that shape from fy. If you differentiate this one with respect to x, what happened to that? 0, right? Yes. Anything else? There's no x in there. So looked at the first one. That takes a little bit of work. So I looked at this one. That's easier to integrate. So I went for that one. And then compare with fx. Make sense? But this is what's going to happen if you try to integrate the fx first. Look at that. And oh, what is the... Think about the y being pi. And using the u substitution, then you realize, oh, that's 2x out there. So u substitution will work, treating y as constant. Any question? And then I didn't finish it. And with this one, you have to compare with the fy. And this time, this phi y actually picks up this e to the y, right? Not constant. If you approach it this way. Good. It's more exercise with gradient of 27. Let's focus on just computing the gradient of this one. It's 3 variable. Use the same idea. This was a homework problem, right? Let me first ask, was that okay? To dealing with a 2 more variable, 1 more variable, a 3 variable? So can we skip this? Is that okay? All right. So let's not do it. Let me just talk about this problem, number 4. And this is actually the proof of what theorem is this? What was the name of the theorem? Yeah, fundamental theorem of line integrals, right? And I broke it down into step by step. So did each part make sense, my solution? Yes. So that's actually, if you look at it, it's very simple. The proof is very simple, but it's to comprehend physically and geometrically is, to me, is almost impossible. Why is path independence, right? So what was the key part in here? A, B, C, D. What was the most interesting part to you? To me, that was definitely C. What was that theorem that changed this inside to that? Yeah, multivariable chain rule, right? Multivariable and chain rule. That changes to that. We've been dealing with this all the time in that second derivative test and all that, right? We looked at it a couple of times. Now you have a new meaning, this one, right? This is actually dot product of two things, right? We saw that in the gradient vector field. So very interesting. So I will just leave it at that. And